Hello, today we are talking about chords, secant segments, and tangent segments. So you will need a calculator to do this video lesson. So if you do not have one, please pause the video and get one. You're welcome to use the one on your phone. We're just doing basic multiplication and division. So the first thing that we see here is that we have when two chords intersect inside of a circle. So we have two segments, they are inside of a circle. Then we have this relationship. We have that A, which is right here. When I multiply that by B, which is right here, I'm going to get the same thing as when I take C, which is one piece, and I multiply that by D, which is the other piece. So basically all this says is two chords intersect each other, multiply the two pieces of one chord together, and that will be equal to when you multiply the two pieces of the other chord together. This is something that you must memorize. This is not a formula that you are going to get. So please, please, please memorize this. So let's go to the try this. Solve for x. What I'd like for you to do right now is I would like for you to go ahead and try and write a setup. So pause the video and write the setup for finding x. Pause the video now, please. So this is the setup that I have. Again, the two pieces of one chord are x and 26. When I multiply those together, that's going to be equal to when I multiply the two pieces of the other chord together, 15 and 20. This is where your calculator is going to come in handy. So I can rewrite x times 26 as 26x. That's typically how we would write it. And then 15 times 20 using your calculator, we should get 300. And at this point, I'm just going to finish up with some algebra. Divide both sides by 26. And again, using your calculator, 300 divided by 26. And I get 11.538. If you have any questions about that one, pause the video and take a look and see if you can figure out the algebra. Otherwise, go ahead and bring it into your teacher next class. Moving on to the next style problem. Now in the first one, the two segments we were talking about were inside the circle completely. Now we're talking about two segments where part of the segment is inside the circle and part of the segment is outside of the circle. So this is a formula that, again, you've got to memorize. This will not be provided. So please memorize this formula as well. So what we have going on, if you look up at the top, we have the outer part of one segment, and again, that's the part that is outside of the circle. And then we're going to multiply that by the entire secant. The entire secant is the whole thing from the outside of the circle to the very end of the circle. It's that whole piece there. And then we do the same thing with our other secant. So we take the outer part, which is the part that's outside of the circle, and we're going to multiply that by the entire secant right here. Now, another way to think about this formula is that we take the outer part, I'm going to call that O, and I multiply that by the whole secant. So this stands for the whole secant, the whole segment, and O stands for the outer part. So we can say ow is equal to the other ow, the outside part of the second secant times the entire part of the second secant. Again, whatever method you use is fine, but you need to memorize this formula. Okay, moving on to the next page. So here we have an example, and we're just going to work this out step by step. So the first thing we need to do is look at the top secant, and that's the one that's got the 14 and the 20. And what is the outer part? Well, the outer part is from here till I get to the circle, and that's 14. Then it says, okay, how big is the entire secant? Well, that's from here all the way to the end of the circle. So how big is this entire thing? That's going to be the outer part, which was 14, plus the inner part, which is 20. So I'm going to add those two together, and that entire secant is going to be 34 when I add those two together. Now I'm going to do the exact same thing for the bottom secant. That's the one with the 16 and the x. So the outer part of the bottom secant is this green part, which is just 16. The entire secant, or the whole secant, is this whole thing. And I'm going to do exactly what I did with the top secant. Don't let it scare you. The outer part is 16, and I'm going to add it to the inner part, which is x. So I'm going to call that entire secant 16 plus x. And I would advise you go ahead and put parentheses around that, because we are going to be multiplying, and we don't want to forget to distribute. So I have all the parts. Let's go ahead and write up an equation now. So again, I'm using ow equals ow. I'm trying to color code it, so I keep it the same. So the outer part of the top secant was 14. The whole secant of the top secant was 34. So I'm going to multiply those two together. And then for the bottom secant, the outer part was 16. And the whole part, again in parentheses, is 16 plus x. So that's the geometry. We've done the geometry, and that's great. At this point, we need to do our algebra. I'm going to scroll down just so I have more room to work. So again, using my calculator, I'm going to multiply 14 times 34. So 14 times 34, that gives me 476. And then I need to remember with my algebra to distribute. 16 times 16. So I need to do 16 times 16. That's 256. And then I need to do 16 times x. Well, 16 times x is 16x. So from here, I've done the sort of the difficult part of the algebra. Now I'm just getting x by itself. So the first thing I need to do to get x by itself is subtract the 256 from both sides. When I take 476 and I subtract 256, I get 220. And that is equal to 16x. So to get x by itself, I need to divide by 16. And 220 divided by 16 in my calculator is 13.75. And you'll notice we've been getting decimals. In this unit, you are going to get quite a few decimals in your answers. So if you have any questions about this one, pause the video, see if you can figure out the algebra. And if you still can't figure it out, go ahead and write your question down and bring it to your teacher next class. Moving on to the U-try. What I'd like for you to do right now is go ahead and try to do the setup for this problem. So write down the initial equation using the geometry. Don't work the algebra yet, just write down the initial equation. So go ahead and pause the video now, please. Here is my setup. I'm going to go ahead and walk through how I got that. If you don't have any questions about how I got that, go ahead and you work the algebra while I talk about the setup. So I'm going to do ow equals ow. So my outer part for my first segment is 5. And then my whole segment is this whole thing. And again, with this, I'm going to take 5 plus 8. 5 plus 8 is 13. So that's going to be my 13. Then with my other ow, I have my outer part, which is 4. And I'm going to multiply that by the whole part, which is this. And again, I'm going to add the two pieces. That's 4 plus x. And I set those two equal to each other. So from here, now that you've got the setup, I'd like you to, if you have not done the algebra yet, pause the video and work out the algebra. So go ahead and pause the video now, please. Here's my solution. My answer is x is 2.25. If you have any questions, pause the video now, please, so that you can look through the algebra and figure out what I did. If you still have questions, bring them to your teacher. Okay, moving on to the next thing. We're really going to do some algebra here. We're going to be solving a quadratic. That means we're going to have an x squared in the problem, which is okay. We're going to walk right through it to figure out how to do this. So again, our setup is going to be ow equals ow. So the outside part of the first secant is x, and then the whole secant is going to be, I add the two pieces, and that's x plus 1, and of course I'm going to put parentheses around that. And that equals the ow of the second secant, and the outside part is 2, and then the whole thing, I add these two together, 2 plus 4, which is 6. Okay, so this we should have been okay with, writing the setup. Now we're going to have to do some distribution. Now, when I take x and I multiply it times x, so I have x times x. That's very different than x plus x. This is not what I have. Don't write this down. If I had x plus x, that gives me how many x's? Well, there's 2. That's 2x. If I have x times x, I'm multiplying them together, and that gives me x squared. So there's a very, very big difference between when you multiply the two x's and you add them. So back to our problem. X times x gives me x squared, and continue to distribute, I have x times 1 is just 1x. You may write the 1 in front of there if you would like, or you can just write it as x. Equals 2 times 6, which is 12. Now from here, this is what I meant when I said we're going to have a quadratic. So here's our quadratic. We have an x squared. So the first thing that I need to do when I have a quadratic is I need to get 0 on one side. So to do that, I need to subtract 12. Now, with my rules for algebra, I should combine my like terms. But does 12 match up with the x squared? Nope. So the x squared is just x squared. Does the 12 combine with the x? Are they like terms? No. The x is its own term, and the 12 is its own term. So this is what I end up with when I subtract 12 from both sides. So now I'm moving on to step 2. Step 2, I'm trying to find two numbers. Now, the two numbers that I want have to do certain things. They need to multiply to negative 12. And that negative 12 is coming from right here. And not only do they have to multiply to negative 12, they must also, they must add to the number of x's. So how many x's do I really have? When we talked about that, we could write it two ways. We could write that as x or as 1x. So that tells me the number of x's is 1. So I'm looking for two numbers that when I multiply them gives me 12, negative 12. And when I add them, I get 1. So let's start by multiplying. Negative 1 times 12, that gives me negative 12. But if I were to add those together, negative 1 plus 12, does that give me 1? No, that does not work. Let's try negative 2 and 6. Negative 2 times 6 gives me 12, but negative 2, when I add it to 6, is that equal to 1? And no, that's not. Negative 3 and 4, when I multiply those two numbers, I get 12. When I add them, negative 3 plus 4, does that give me 1? And it does. Negative 3 plus 4 gives me 1. So back to actually solving this problem, what we need to do now is factor this. Now to factor, I'm going to use an area model. So to do an area model, I'm first going to create myself a little grid. And in this grid, inside the green, that's where I'm going to put x squared plus x minus 12. So x squared is pretty easy. X squared goes in the very first box within that green part. The negative 12 goes diagonal to that. Goes down here. Well, what are we going to do with this negative 3 and positive 4? That's going to be our x's. Negative 3, x goes in one spot, and positive 4x goes in the other. So the negative 3 and 4 are really the coefficients for the x's. So if you were to look at what's inside the green and combine like terms, you would get x squared, When you add your negative 3x plus 4x, you get the x, and then you have the negative 12. So I've just rewritten what I initially had up here in a little different form. So now I'm going to actually just look at finding area models. When I look at this first row, I have an x squared and I have a 4x. There is something that I can factor out of both by GCF, and that thing is an x. So I can take an x out here. Let's go ahead and look right here for just a minute. What do I have to multiply x by to get x squared? Well, that's x. So you can see the area model. To get the box that I have in the circle, I multiply the x up top times the x on the side, and that gives me x squared. Now I should be able to move across. So I'm going to move across to the arrow I highlighted with red. And this box, the area is 4 times x. Well, over here I know one side is x, which means the other side, when I multiply it by x, should give me 4x. So this is going to be 4. So let's go down to the bottom now. Got that in blue. So I need to find my negative 3x. Well, I know up here is an x. What do I multiply x by to get the negative 3x? It's negative 3. Then moving on to the other box, I have a negative 12. Well, up here I have a 4. What do I multiply 4 by so that I get negative 12? That's negative 3. So that looks great. At this point, I'm going to rewrite what I had with these things as factors. So I take the top, which is really an x and a 4, and that 4 is positive, so it's really x plus 4. And then along the side, over here, I have x minus 3, and that is still all equal to 0. So when I want this to be equal to 0, I take each set of parentheses and set them equal to 0. So I add 4 to both sides with this one, and that gives me x is equal to 4. I add 3, sorry, I did that wrong. I miswrote this, I apologize. This first parentheses was x plus 4. So I subtract 4 from both sides, and I get x is negative 4. Back to the other one, when I add 3 to both sides, I get x is equal to 3. Now I go back to the geometry and look and see what makes sense. Does it make sense that the red outer part of the segment is negative 4? Probably not. We don't measure negative 4 centimeters, which means the only answer that is going to work is x is equal to 3. If you have any questions, write them down to bring them to your teacher next class. So I'm going to go on to the next one. We're going to do it together as well. What I would like for you to do first, however, is I would like for you to write down the setup using the algebra knowledge, the geometry knowledge for this problem. So go ahead and pause the video now and write the setup for the geometry. Here is my geometry setup, ow equals ow. So from here, we're going to go ahead and do our algebra. So first, I'm going to distribute, and again, x times x is x squared. X times 3 is 3x. And 2 times 14 is 28. So the next step, whenever we have a quadratic, we've got an x squared. There it is. So we need to get a 0 on one side. So we subtract 28, and again, this 28 isn't going to combine with anything. It just gives us 3 terms. We put the x squared first, we put the x term second, and then the plain old number goes last. So now we're looking for 2 numbers. We want 2 numbers. They are going to multiply to negative 28, and these 2 numbers are also going to add to however many x's we have, which would be 3. So let's look at some numbers. We've got negative 1 and 28, but those are not going to add to 3. We have negative 2 times 14. Those don't add to 3. 3 doesn't divide evenly into 28. Negative 4 and positive 7, I think that works. Negative 4 plus 7, is that equal to 3? And it is. So those are the 2 numbers that I want. So I'm going to create my grid again for my area model. Again, inside what I'm coloring is the green, is where I'm going to put x squared plus 3x minus 28, written a little differently. My x squared goes in the top left box. My 28 goes in the bottom right box. And then the two numbers that I found, negative 4, that's really negative 4x, and 7 is really 7x. And again, it doesn't matter where you put them, negative 4x plus 7x. In your last two boxes, it doesn't matter where you put them. And again, I'm going to start here and here. What two things multiply to give you x squared? And that will be x times x. And from here, and again, it doesn't matter where you move. You can go anywhere you want. I'm going to go to this box that I've circled in blue. Inside here, I have 7x. My x is to the left, which means what do I multiply x by to get 7x? And that's a 7. I'm going to go ahead and write positive 7, just because it is positive. Moving to the last empty box that we have, outside is here. We're going to go ahead and let's look at this first one that I've circled in black. Negative 4x, my x is right at the top, which means what do I multiply x by to get negative 4x? And that's negative 4. Here are my two factors. So I'm going to write my two factors, x plus 7 from the top times x minus 4 on this side, and then I'm going to set each of those equal to 0, and hopefully do that part right this time. Subtract 7 from both sides, x is equal to negative 7, add 4 to both sides, and x is equal to 4. I go back to the geometry problem, and which one of these makes sense? And the one that makes sense is x being positive 4, because again, we would not have a negative 7 centimeters. If you still have questions, pause the video, take a look. Other questions, write them down, bring them to your teacher. Moving on to the last one. This is still the same process, even though it looks a little bit different. So we're still going to do ow equals ow. The outside part in this one is 3. The whole secant segment right here is 3 plus x. So that's my outside part is 3 plus x. And that's going to equal to the outside part of the bottom, which is 6, times the whole bottom, which is the same. The outside and the whole are the same. So we have this situation. So we can work that out. Again, algebra, distribute. 3 times 3 is 9. 3 times x is 3x. 6 times 6 is 36, and I can work my algebra now. Subtract 9 from both sides, and I get 3x is equal to 27. Divide by 3, and I get x is 9. If you are satisfied with the way that you did this, you may stop the video right now. I'm going to show one additional way that you do not have to know to do, just another way. If you want to just keep watching, you're welcome to keep watching. So I'm going to do the same kind of setup, but instead of writing the whole secant as 3 plus x, I'm just going to call that y. So for example, if I end up that y is equal to 10, let's say I work the problem out and y is 10, once I know that this part is 3, what does that leave for x? Well, that leaves 10 minus 3, which is 7. So x would be 7. So that's the idea that I'm using for this one, is I'm just going to call this whole thing y when I do my ow. So working that, my outside part of the first one is still 3. The whole segment, I'm calling that y. And then, of course, in the bottom, the outside part is 6, and the whole secant is still 6. That's supposed to be a w. So from here, I can go ahead and do my algebra, which is a lot simpler. I now just have 3y is equal to 36. Divide both sides by 3, and y is equal to 12. Once I know that y is 12, let's change this y to a 12. This whole thing is 12. How big does that mean x has to be if the front part, the outside part, is 3? Well, it's going to be 12 minus 3, which is 9. So that gives me x is equal to 9. So that adds a little step in the end. However, it reduces the algebra that you need to do. So I hope you enjoyed this lesson. Bring any questions that you have to class and have a wonderful evening.